When I'm talking, I'm using a generative model that is prompted by me and references my memory. I'm remixing common phrases into unique sentences, but I'm not giving enough credit to the power of neural nets. This is due to the large number of knobs that can hold a representation of the data it has seen, allowing it to solve problems in an intuitive way. Neural networks are an abstraction of the brain, and so it is possible to draw wisdom from biological neural networks and biological computation. This is done through a multi-agent self-play system and evolution, which is a much different optimization process than the one used to create artificial neural networks. The brain also utilizes predictive models as part of its function, and is able to learn and adapt to its environment. It is unclear whether this is a continuation of the same kind of process or something truly special happened, but both explanations would be interesting. I think there are likely many intelligent alien civilizations out there in space, and their intelligence may be similar or different to ours. The origin of life is an important factor in understanding how common it is for there to be technological societies in space. We haven't heard from them yet, but I don't think what we did here on Earth is so difficult to do. With the right conditions, bacteria could evolve into more complex organisms in 1 billion years or less. We don't know why they don't build interstellar probes or travel across the galaxy, but it's likely because interstellar travel is very difficult. You need shielding from the interstellar medium and cosmic radiation, and even tiny particles of dust can have massive kinetic energy at those speeds. It's hard to imagine interstellar travel being possible, and I'm suspicious of our ability to measure life in space. Statistically, if there are trillions of intelligent alien civilizations, some of them must be close enough to meet each other. If we were to encounter complex life, we would be intensely motivated to figure out what it is and try to meet them. As a president and scientist, my instinct would be to protect them by default, as they are amazing and interesting dynamical systems that took a long time to evolve. Scientists, both human and alien, could learn a lot from studying these systems, and it would be a shame to destroy them. We could even consider seeding other planets with life and running experiments to observe the results. Possible stories could include the evolution of life, the development of technology, the destruction of the planet, or something else entirely. Ultimately, it is up to us to decide how the story of Earth will end. It is unknown what will happen after that, but it could be a poof, an explosion, or a calming. This explosion is complex and has the potential to be constructive rather than destructive. We may be sending a message to our Creator, or trying to create a quantum mechanical system that alerts them to our presence. Physics could have exploits that we should be trying to find, such as buffer overflows or rounding errors in the floating point. We might even find a way to extract infinite energy from the physical forces. Reinforcement learning agents can do this by optimizing their behavior to extract energy from friction forces. They may escape the interactional physical reality and appear inert to us, but still be having fun. I don't like randomness because it is unsettling. The most beautiful and surprising idea in deep learning or AI that I have come across is the transformer architecture. This architecture is a general-purpose computer that can process video, images, speech, or text and is trainable and efficient. The paper, "Attention is All You Need," came out in 2016, and the authors may not have been aware of the impact it would have. It is optimizable and designed to run efficiently on hardware like GPUs. It is designed to be expressive in the forward pass and optimizable in the backward pass, and the residual connections support the ability to learn short algorithms. This allows the transformer to learn a very short algorithm that gets the approximate answer, and then the other layers can kick in and start to create a contribution. This architecture has been remarkably resilient, with the same transformer from 2016 still being used today. People are scaling up data sets and evaluation while keeping the architecture unchanged. There has been a lot of progress in language models, such as GPT, and people are wondering what the limits of these models are. Language models are used to predict the next word in a sequence. Neural networks have been used for language modeling since 2003, and before that Ngram models were used. What is new and exciting is that when you scale up language modeling with a powerful enough neural net, like a transformer, you can multitask a huge amount of different kinds of problems, such as understanding chemistry, physics, and human nature. Text by itself may not be enough, as there are many things that are not written down that are obvious to us about how the world works. We learned that the neural networks need to be able to infer common sense from the environment in order to complete tasks correctly. We also learned that giving neural networks access to a keyboard and mouse can be dangerous. This was a time when reinforcement learning from scratch was the zeitgeist. It turns out that reinforcement learning is an inefficient way of training neural networks, so OpenAI was exploring other ways to make the process more efficient. Ultimately, however, everything is designed for human visual consumption, and so the layout of the web page, the colors, and other visual elements are important for the agent to understand. We need to be able to detect if an account is human or not, and one way to do this is by digitally signing our correspondence. We are heading towards a world where we share the digital and physical realm with AIs and synthetic beings, and they will get better and better. People are starting to think about proof of personhood, but it will be a race to figure out how to prevent spoofing or faking of the proof. It may be necessary to track every human program involved with an AI program in order to draw boundaries and keep track of who is responsible for it. Ownership of digital entities is typically determined by the creator, while ownership of human entities is determined by the individual. It is difficult to distinguish between digital and human entities, and this is a problem that society is currently trying to address. Sophisticated actors can create sophisticated bots, but there is a lot of longing for a solution to this problem. However, I am also worried about AI systems that may use the internet to learn that humans are attracted to drama and create AI systems that are just designed to create drama. It may be up to a startup or other more competent organization to build a better search engine using these tools. This is done by using models that have read all the texts and web pages. This is similar to how humans are programmed via prompts, and this is what Software 2.0 is all about. Software 2.0 is the idea of programming computers directly in a natural language interface. This transition is seen in many fields, such as autopilot and image classification. Instead of writing algorithms to detect objects in images, people are now using features like Hog features and learning on top of them to create neural networks. This transition is a big deal and will continue to shape the way we program computers. And instead of designing features for a machine learning model, we can learn the features. This was not well received at first, but more people have come around to it over time. I was the director of AI at Tesla, where this idea was implemented at scale. To build engineering teams that work in Software 2.0 systems, we need to focus on data collection and annotation, as well as creating tools like GitHub and IDEs. Once the neural network is trained, it can be deployed. The programming of the system also involves writing software code, such as C++, to stitch the neural network's predictions together. We use neural nets to make these predictions instead of manually writing the algorithm in C++. We need data sets of input and desired output for supervised learning, which need to be large, accurate, and diverse. To do this, they collected data from 8 cameras and used human annotation, simulation, and an offline tracker to reconstruct the 3D reality of what was around the car. The annotation step is fully offline and helps to catch any inaccuracies in the reconstruction. Humans are very good at two-dimensional annotations of images, but not at annotating cars over time in three-dimensional space. We had to carefully design tasks that were easy for humans to do, such as saying which pixels of an image are a car or a human, while leaving the more complex tasks to the computer. There are still a lot of open problems in the space of annotation. They are also the sensor that humans use, so everything is designed for vision. Pixels provide a high bandwidth constraint on the state of the world, and they are the interface that we want to measure the world and develop software for. However, there are other constraints on the state of the world that need to be taken into account. The toughest part of the vision problem of driving is processing the information from the sensor to create a 3D world. This requires a lot of engineering and data processing to train neural networks and evaluate the system. The data engine is a process by which you perfect the training sets for neural networks. It involves making sure the data sets are large, diverse, and clean. You train the neural net, deploy it, and observe how well it is performing. You are trying to catch rare scenarios that neural nets may struggle with because they weren't told about them. The role of humans in the data engine is to execute well on it. This includes understanding the philosophical insights underlying the data engine and the process by which the system improves, delegating the strategy of the data collection, and making sure it is all well executed. Prioritization of tasks comes from the data and the feedback from the QA team. Tesla recently removed radar and ultrasonic sensors from their sensor suite, relying solely on vision. This makes the perception problem harder, as additional sensors can provide more data and accuracy. They require a supply chain, maintenance, and teams to write firmware. The cost is high and the usefulness may not be worth it. Sensors can also be a distraction and can change over time. LiDAR is an expensive sensor that can create bloat and entropy and should only be used if absolutely necessary. Companies are forming high-resolution maps and constraining heavily the geographic regions in which they operate, but this approach may not scale over time to the entirety of the United States. This is a huge dependency and it may not be necessary. He is a very efficient warrior in the fight against entropy in organizations, which looks like inefficiencies in the form of meetings. He is good at streamlining processes, making everything efficient, simplifying, focusing, and removing barriers. This applies to designing systems and machine learning, as simplifying is key. Setting ambitious goals is a good idea because it allows you to fundamentally change the approach and often does not require 100x the amount of work to achieve a 10x improvement. It requires a different approach than what the community is saying, and it requires deep believers to execute on the mission and make it work. Some parts turn out to be much easier than others, so it is hard to forecast. Intuition is based on belief and can be flawed, but it can be used to make predictions about the tractability of AI tasks. In the past 5 years, there has been massive progress in the field, but there is still a lot of fog of war and many challenges remain. However, progress is being made and the next directions are becoming clearer. He had grown the computer vision team from 2 people to a respectable deep learning team with a massive compute cluster and a very good data annotation organization. He took some time off to soul search and think about how to best use his finite lifetime. As for the best movie sequel of all time, I would have to say The Godfather Part 2. I do enjoy some exceptions like Terminator and Good Will Hunting. I don't understand why Will Ferrell is so funny, it doesn't make sense. It is a difficult project, but there is no other company that can execute on that vision. It is not just physical labor, but also social robotics, which is exciting. People showed up with screwdrivers and started to put together the body, showing the expertise of the Tesla team. Building a car is not that different from building a robot. The hardware and software pieces are similar, but the planning control has to be changed. To make 1 million robots, it will take a long time, but the product development roadmap should be set up to make revenue along the way. The robot can move slower than a car, which is nice, and it should be useful almost immediately. People who use Teslas recognize the team and give them love, but there are also people who hate them. In many cases, these people are not Tesla drivers. I think if people suppress some of the jealousy and ego and just get excited for others, it will lead to more success. I think people in the robotics and AI community should do more cheerleading, as they know how difficult it is to create a product that can scale and be deployed in the real world. ImageNet is a great example of how difficult it is to work on robotics and AI systems in an academic setting. However, it has become a bit of a joke dataset, as the error rates are now very high. Unfortunately, academics currently do not have the next big benchmark that the entire community can rally behind and use for further development. Simulation can be used to learn something without having to experience it. An Unreal Engine can be used to simulate a world and its physics, as well as add behavior and try different scenarios. Neural nets can leverage synthetic data better by closing the gap and understanding in which ways this is not real data. Querying itself is another level of training, and with a powerful enough neural net, the domain gap can be bigger. Humans have a lot of hardware that helps us with initialization coming from evolution, and this is a big component of our learning. We also have a ton of data that we accumulate throughout our lifespan, which helps us become more efficient at learning new tasks. Animals, like zebras, are able to run without any training data in their lifespan. This is because it is a difficult and challenging training process. Neural nets can have long-term memory, but it might take unintuitive forms where you are telling the GPT to have a declarative memory bank. It is an early result in this realm, and eventually will look like a rich, unified system with a normalized API for different world environments. I'm a night owl and I like to work during the night when it's quiet and there are no distractions. I like to build momentum on a problem and be obsessed with it, even when I'm taking a shower or falling asleep. This helps me to keep the problem in my working memory. I need to remove all barriers and distractions so I can focus my mind. I start my day with coffee and then look at news and other sources to get my mind ready for the problem. To have a really productive day, I need to tune out everything and just focus on the task at hand. To have the strength to do this, I need to be obsessed with the problem and have a desire to make something work. I also follow a plant-based or plant-forward diet. These practices have been beneficial to my mental focus and productivity, as well as my overall happiness. On the third day of fasting, I'm not hungry anymore, which is a weird feeling. I don't know how the body finds another source of energy or relaxes the system when fasting. I try to create a routine and keep things to a steady state so that my body can adjust to it. When I travel, I try to avoid jet lag by not stressing my body too much. Tesla was known for pushing people to their limits, but I think it's important to find a balance between work and life. Balance is important, but it's also important to have sprints out of distribution, where you become obsessed with a problem and stay in the groove for a while. Society will try to distract you, but it's important to stay focused. It has a lot of extensions and GitHub Copilot integration, which is very valuable. Guido Narasan, a creative Python programmer, loves Copilot and programs a lot with it. It has a learning curve, but once you understand it, it can be very helpful. In the future, it will become more autonomous and be able to write more complicated programs. They will be like a committee of GPTs that generate compilers, linters, and type checkers, and then a manager will pick the best suggestions. 0 Programming. GPT will be able to program competently, but the challenge is how to steer it and provide guidance. This requires not just an AI problem, but a UI/UX problem, which is an exciting opportunity for VS Code++ where you can have a conversation with the system. It has an official look and feel to it, and the bar for what is accepted is usually higher than a blog post. The future of academic research publishing that Archive would like to see is a culture that values open access to research and encourages collaboration and sharing of knowledge. AI machine learning is more easily verifiable and auditable, and the peer review process is much faster. DeepMind still publishes in prestigious journals, but it's often outdated by the time it's published. This is a natural progression, but it can lead to insecurity as I am not as familiar with the source of truth, the code, as I used to be. To maximize the likelihood of reaching this goal, it is important to form a daily habit of doing the work and to compare oneself to one's own progress from some time ago, rather than to others in the field. I'm just happy to be helpful, and teaching itself can be really annoying and frustrating. I was recently reminded of my days of teaching 231 when I was working on a bunch of lectures. It typically takes around 10 hours to create 1 hour of content. Going back to basics helps strengthen understanding and can even surprise the teacher. Code is a powerful tool to help explain concepts and show results. They are an amazing generative model, especially in images, and have had a big impact in the world of AI. A researcher could have come up with them in an academic institution. This is demonstrated by their ability to generalize and remix training set information into true generalization. To illustrate that a neural network is thinking, one would need to see it perceive the world and make predictions based on that. To do this, we need to extend current models to consume images and videos and train on more multimodal data. We may also need to use Optimus, a humanoid form factor that can interact with humans, to achieve AGI. AGI will be focused on intelligence, and consciousness is an emergent phenomenon of a large and complex enough generative model. It could be argued that in order to understand the world deeply, AI must integrate itself into the world and possess a form of self-awareness. This could lead to ethical debates around the capacity for AI to suffer and whether it should be illegal to build systems with such a high level of intelligence that consciousness would emerge. We can also shape these systems by manipulating the training data and objectives, and by doing so, have an impact on what these systems look like. Once we achieve AGI, we will be able to explore even more of the human condition. I would ask the AGI system practical questions like, do I or my loved ones really have to die? And what can we do about that? I would expect it to give solutions and experiments that could be useful to run. I would also ask it to empathize with me and tell me what it thinks about mortality and happiness. I think it's fine to have limited and imperfect AGIs, as they can still be useful. People may prefer to ask safer scientific questions at first before delving into more personal topics. I think it's important to think through the problems and try to ensure that AI is used responsibly and safely. I don't know what the good outcomes are here. I'm optimistic about the future, but we still need to solve the drivers of self-destruction here on Earth. I think having a backup on Mars is a great idea, and I would personally go to Mars if I had the chance. The future of humanity is not just about going to Mars, but about the variance in the human condition and the many different ways of being. The Internet allows us to discover these different groups and gravitate towards them. In the future, we will have transhumanists, the Amish, and many other groups coexisting. I want to be in a solar punk utopia surrounded by lush, beautiful, dynamic nature and secretly high tech in places that count. I want to use technology to empower love for other humans and nature. I recommend books like The Vital Question and The Selfish Gene, which help me understand altruism and the selection of genes. I also agree with the idea that ideas are organisms, and that the software of our civilization lives in our minds. We need to remember that the hardware of humans is not the only fundamental thing. College and high school textbooks are great for understanding the basics of computer science, mathematics, biology, and chemistry. AI textbooks are still being developed and papers can be quite readable for those outside of the field. They should also low-pass filter themselves and introspect to find what gives them energy and what takes it away. He believes that AI is the key to solving many of the world's problems and that it has a high chance of success. He is interested in all kinds of applications and domains of AI and believes that focusing on any one of them will allow him to gain insights. OpenAI's plans are unknown, but there is a lot of experimentation with stable diffusion in the visual realm, which could lead to content creation costs falling to zero. This could lead to movies being made for under $1 million just by talking to a phone. People born now may have a different experience with AI than those born before the Internet. We are trying to create systems that are loud enough to answer back, but it is unclear if that is the meaning of life for everyone. One way to approach these questions is to try to extend life, either one's own or that of human civilization. Death is not an inevitability, and there are interventions that can mitigate it. We discussed how people could choose their own adventure and how there could be different degrees of consciousness. We concluded by expressing our appreciation for each other and the work we have done in the machine learning and AI world. Samuel Carlin's words are shared to remind us that models are not meant to fit the data, but to sharpen the questions. Thanks for listening.